Fiat Lux. Welcome everybody. My name's Robert Smallshire. I'm a consultant. And I use that word consultant in the very much in the English sense of the word rather than the Norwegian sense of the word, in that by and large I am the kind of person you hire in order that I can tell you what to do rather than a kind of contractor, which is really what it means in the Scandinavian languages, where you hire me to do what you want me to do. So I'm here to give advice, and this talk is very much a collection of advice that I have gathered over my 20 years or so working as a professional software developer in various technologies. Those particular technologies aren't very important today, and also working in various software architecture roles at different levels. I want to lead into this talk by really thinking about demographics, and I was given a wonderful setup by a gentleman who just approached me literally 2 minutes ago and offered me a chair. And I thought, does that mean I'm old? And here's the chair. And after about 20 minutes into this talk, I may need it, because I'm in my 40s, and that makes me significantly older than most of the people in our industry. And that's a very interesting and significant fact, the fact that being in my mid-40s makes me older probably than most of the people in this room, and certainly most of the people at this conference. Because the demographics of our industry very much affect the way we approach problem solving. We are almost unique, I think, in having being an exponentially growing industry of people, of developers, architects, designers, all the people involved in building software. And in any system where you have exponential growth, the newcomers will outnumber the old-timers very quickly. That is just a fact of the way exponential growth works. So the fact that I'm in a minority because I'm old is really because the growth of the industry is so rapid. So maybe this talk is about software architecture, maybe it's also a kind of coded attack on ageism in the industry, but you can make your own mind up over the next hour or so. So exponential growth is something that characterizes the demographics. There's another interesting aspect to the demographics in our industry, which is that many of us did not, and I include myself in this, receive a formal education in software engineering or software architecture. Many of us will have had an education in computing science, but of course you know that computing science is very much about computing and about computation, has very little to do with computers if it's done in a pure way, and has almost nothing to say about software engineering. Another factor to do with the demographics of who we are as a community is to do with turnover. So I've worked on many different projects in my career, and I've become interested in how long successful code bases last. Those which become legacy software, they last decades, if they're successful. Versus how long individual developers are allocated to that particular project. What is the tenure of a developer? And I think this is a very interesting question to compare the lifetime of software systems versus the engagement of an individual developer or designer or whoever with that system. And there are various ways you can think about turnover, and one of the ways you can think about it is as half-life. And so the half-life of a developer, of developers as a community, is how long does it take for half of the developers on a particular project to move on to some other project, or resign, or die, or whatever. You know, various things happen to people. And it turns out that that number is about 3.5 years. So every 3.5 years, you can expect half the people you're working with now on whatever project that is to move on to something else. Depending on what industry you're in, that may, obviously you need to calibrate those kind of numbers to your own industry. Some industries, those tenures are much longer. In other industries, they're much shorter. But the fact is that 3.5 years of a half-life is relatively short compared to the lifetime of successful software systems. Bear in mind that being a half-life doesn't mean that the average tenure is 3.5 years. You have to divide it by, what, the natural logarithm of 2 or something. So the average tenure is about 4.5 years. But taken together, these factors of exponentially growing community, the fact that many of us are not properly educated in software engineering and software architecture, the fact that many of us are new and don't have the experience, and by and large we don't hire architects straight out of school. It's something that I think most people would agree requires some experience to be good at, means that really we are a community of enthusiastic amateurs. And in any situation where you have a community of enthusiastic amateurs, we have to come up with some heuristics for how we approach designing software. And our industry has landed on an extraordinarily simple heuristic for how we go about designing software, which is just to follow fashion. So let's think about clothing and fashion. What are the functional requirements for clothing? Come on, you're all wearing clothes, thankfully. Right? Most of you will wear clothes every day. What are the functional requirements for clothing? They keep you warm, right? They protect you from the elements, right? From the weather, okay? They stop you getting cold, they stop you getting wet. They cover you up, right? They protect your modesty, right? Thankfully, you've all chosen to come here wearing clothes today. And you probably think the same about me. So there are really two important functional requirements for clothing: protection from the elements and modesty. However, does clothing change? On a pretty rapid basis, right? Particularly if you follow the literature, if I hesitate to call it that. If you follow the literature in the fashion industry, in Cosmo or Elle magazine, then you will find that fashion changes certainly every year and often more quickly than that. And, you know, we laugh at this because we're all engineers, right? We don't follow fashion. We make design decisions based upon the evidence. But, you know, there isn't just Elle and Cosmo and Teen Vogue and Fashion Magazine. There's Microservices Weekly. And in the same way that if you're not wearing the right jacket, then you're going to get ostracized from parties. People won't speak to you. They may not even invite you to those parties. Then, if you're not pursuing the right kind of software architecture, then you might suffer some kind of social ostracism in our own community. What do you mean you're building a monolith? Now, before I move on, I want to give you perhaps the only really concrete piece of software architecture advice, or prediction if you like, which is that this fall, or in English, autumn, layered architectures are in. So you know what's coming. So this very kind of visual marketing-driven approach to fashion is something that we also see in our own industry. These kind of visual metaphors crop up all the time. And I haven't needed to draw these things. You can very easily find these kind of things on the internet. We will all have heard of spaghetti code, right? We have these little microservices down at the bottom right there. They look like little cells kind of interacting, or bacteria, or amoeba maybe. We have pies, we have machines with gear wheels. And these depictions are from what I what the people who run them would probably like me to call serious consultancies. But here we are. We're essentially marketing fashionable architectures through pictures. And of course, flavor du jour is the cupcake. The microservice, here depicted as cupcakes complete with cherries on top. And of course, we all like cupcakes, right? Who here doesn't like cupcakes? Right? No, two people, my goodness. So I'm not going to invite you to my parties where I serve the most wonderful cupcakes. But for the two people here who don't like cupcakes, that's okay, because you can have microservice donuts. Now, it turns out that the same serious consultancies that produce this kind of marketing bump to persuade you of their collective wisdom also produce something which is perhaps a little more useful as a tool for thinking about how our industry works. And I'm sure many of you will have seen the Gartner hype cycle before. For those of you who haven't, I'm just going to briefly explain it. The Gartner hype cycle is interesting for several reasons we're going to go through. One of the most interesting is that it isn't actually a cycle. But there you go. So, let's talk our way through the hype cycle. You can see on the x-axis here we have a timeline with a series of phases: technology trigger, inflated expectations, disillusionment, enlightenment, and productivity. And along the curve are annotated various types of people who are engaged in adopting these technologies. So right at the beginning with the technology trigger, we have startup companies and first-generation products and early adopters investigating. And then we reach this peak, which is essentially it is the hype cycle. This is a peak of hype. It's maximum marketing, essentially. Even if it's not a formal marketing, it's an informal marketing in the way you might experience at a conference just like this one. And people get very excited. Everybody moves in. You get the gold rush effect. People move into this area and begin adopting the technology, frankly, uncritically. And we'll talk about what motivates people to do these kind of things in a minute. Then, over time, people begin to understand and experience, crucially experience, the real-world implications of what they've chosen to do. Okay? So, all these things that seemed like a very good idea, when they adopted them at the peak, they understand the shortcomings, they begin to understand the trade-offs. There's a very key word we're going to come back to. And more than likely, they are going to sink into the trough of disillusionment and become disenchanted with the choice they have made. But now they're committed to it, so they're probably paying the price for this. And at this point, many, and perhaps this is where there is a hint of a cycle in this thing, although it's not formally on the diagram, I think a lot of projects get into the trough of disillusionment, become disheartened, abandon the technology, go back to the beginning, and then choose the next big thing, which is right now in the technology trigger phase. So I think maybe there's a route back to the beginning of the diagram that undercuts the peak going in the reverse direction. Some people, however, stick around. They tough it out because they have to, or because they have more experience, maybe. And over time, they ascend the slope of enlightenment. And what's happening here, crucially, is they understand the trade-offs involved in whatever decision they've made. They understand the context in which that technology works well. And crucially, they understand the context in which that technology does not work well and in which not to apply it. The most important word in our industry when it comes to design is context. You have to understand the context in which you're operating, and you have to think critically about whether a choice you make makes sense in your context. And so what people are doing while they're climbing the slope is understanding how that particular technology relates to their context, and then eventually the people who survive that long enter the plateau of productivity, where they can begin doing useful work and delivering value to customers using that technology rather than just faffing around with new bits of code. So this hype cycle is released every year, I think, and it's interesting to look at how different technologies move along the curve over time. But of course, you can make your own hype cycle, because you can just choose things and you can make a judgment about where you think particular technologies or practices or approaches are on the hype cycle. So I've had a go at doing that for various things that crop up in the world of software design and software architecture. So here's my hype cycle, and what we're going to do is look at how various software architectural styles, if you like. So an architectural style is if you can think of it as a kind of large-scale pattern for what kind of software architecture we're going to choose, how those things have traveled along the hype cycle. And some of these things are very old. Architectures like pipes and filters, or plugins, or MVC, or layered architectures, which I mentioned earlier. And most of these architectures these days are well understood. We understand the trade-offs. Crucially, we understand the context in which they apply and the context in which they don't apply. And so, by and large, we can be pretty productive with them if we choose to use them. That said, they're all kind of boring, right? How many MVC talks are there here? Right? Or pipes and filters talks? None. Right? I didn't even check the schedule, but I know it's none. Right? So, even though people are and continue to do useful, interesting, and crucially valuable work using those architectures. Let's look at a few other things. Service-oriented architectures seem to have descended into the trough. Perhaps they will always be in the trough. And it's certainly true that some things never escape the trough. You know, there's a implicit process of Darwinism going on here, and things sometimes don't make it, and that's okay. We have event sourcing. I first heard of event sourcing at a conference in probably about 2010. So we're getting on for a decade into event sourcing now. And I think we've gone through the hype, and I think we are heading into a trough of disillusionment where people will begin to understand some of the negative implications of event sourcing. Some organizations are already discovering that keeping all your data about everybody forever might not necessarily be a great idea. And of course, the poster child for architectural hype, the microservice. Here it is. Do you think it's at the peak? Is the peak in front of us? Is it behind us? If it's behind us, it's not very far behind us, is it? We're close to the peak. So what should focus your mind on the slide as it looks right now is the apparent irony of having service-oriented architectures right in the trough and microservice-oriented architectures right at the peak. Is size the only thing that matters? And then I made this slide a year or so ago, maybe a little longer. So I have serverless right there at the beginning. Today I would probably draw that a little higher up towards the peak. I'm not sure we've reached the peak on serverless yet. I think we have a lot of hype in front of us. But it's interesting to think, when you're assessing which architecture to use, where that sits right now on this curve, because you should use that to calibrate your expectations of how well we understand that particular architecture. You can also put some practices on here. Again, I made this a while ago. I think, and for many people, Agile is well down in the trough right now. I think when I made this, it was on the way into the trough. The reason I don't update this slide for every talk is because it's like a 9-week job to update the animations in this slide. So, so I think for many folks, Agile is in the trough. Certainly, Agile as intended let's interpret agile with a small a as meaning responsive to changing needs, right? I mean, that's not what's really happening. I see a lot of agile theatre and a lot of disillusionment with that. But agile in terms of true responsiveness to changing requirements is not something I see so much of. A lot of software architecture practices, just simple stuff like people drawing pictures. People, in a semi-formal way, people designing software at all in advance. That became very unfashionable during the Agile revolution. Everything was supposed to be emergent, and that's a word I'm going to come back to later. But I think we are on the slope of enlightenment. I think we do have a good understanding of some of these things, and there are good organizations who are making good use of software architecture practices. Other things related to that, like UML, is down there with SOA. It's probably always going to be down there with SOA. When I run software architecture classes these days, essentially nobody uses UML. And partly that's reflected in the fact that UML is something really from the late 90s. And because of the exponential growth in our industry, well, I think we're heading for a time where people I work with are born in the late 90s. So it's, people just haven't been exposed to these things. So why do we have this, this fashion-driven response? Why are people choosing things because they're popular, essentially, rather than because they are necessarily the right answer to their problem? Well, there are a whole bunch of different biases which act on us imperfect humans. And, we like to think that we are highly objective people, right, who make decisions based upon the evidence. The one piece of evidence we do have is that we are almost universally terrible at that, unless we make a conscious effort to correct for those biases. And I probably have 30 cognitive biases here. There are probably hundreds of them. And it's very difficult, of course, to correct for all of them. So I'm just going to highlight 3 or 4 of these things now. So the first one I'm going to highlight is the availability cascade near the top there. So what is the availability cascade? Well, you are probably being subjected to an availability cascade at this very conference. And an availability cascade takes the form of repeated exposure to something makes you think it's a good idea, right? So if you go to 25 talks on microservice architectures, you begin to think it's a good idea. Whether or not it's actually a good idea in your context, right? Just because lots of people say it's a good idea, you begin to think it's a good idea. You begin to exhibit a bias towards it. Similarly for serverless. I'm sure 40 years ago, people were going to conferences and suffering from availability cascade with respect to MVC or pipes and filters, right? The effect is the same. There's nothing specially good or bad about microservices. It's just that that is the thing that's happening right now, or serverless. Another bias I want to highlight is the recency effect. So the recency effect, anyone who's interested in music or films will have, maybe read a newspaper or magazine article, which is, top 50 films ever, right? And these things tend to be heavily biased towards usually the last 18 months, right? So you'll find half the films in the top 50 are just from the last few years, and the other half are from the rest of history. And that's because we attach a much greater importance to things that happened recently. And we see the same here. So, there's a reason people aren't choosing, one of the reasons people aren't choosing pipes and filters architectures, even though they may be highly appropriate in their context, is just because they're old. The one on here that has, I guess, the fanciest name, if I can see it, down at the bottom left here is hyperbolic discounting. So hyperbolic discounting is the bias that means that if I say to you, do you want $100 now or $110 in a week? You go, I'll have $100 now, please, right? The immediacy is worth something to you. Whereas if I say to you, you can have $100 in a year or $110 in a year and a week, then you're prepared to wait, right? For the $110, you'll wait a year and a week for that. So we tend to attach a value to how soon we can deliver things. Essentially, we will attach more value to things that we can have sooner, even if they are intrinsically worth less. That's related to another idea called net present value. And then finally, I guess the one we see most at conferences like this is pro-innovation bias. Just because something is new, it must be better, right? And of course, that isn't always the case. So where does this leave the poor software architect? And you may or may not have architects in your organization. It may be a role that is assumed by people you call developers. You may have specific people doing software architecture. But where does it leave the architect? Well, a lot of people tend to think of architecture as being about the structure of software systems, what components we have, what are the responsibilities of those components, what technologies are used to build those components, how do those components relate to each other, how do we deploy those components, these kind of things, structure. And of course, that is an aspect of software architecture, but that structure needs to be a response to a need, not the driver of the process, right? The structure has to be a response, not the starting point. I think a much better way for software architects to spend their time, or a much more fruitful way to spend them in advance of thinking about the structure, is to think about software qualities and about the trade-offs involved in building software. So we're going to talk a lot about qualities in this talk, because for me, this is very much at the center of what software architecture is all about. And if you think you're doing software architecture by designing the structure of systems without thinking about the qualities of systems, I would go so far as to claim that you're not really doing software architecture. So I've put up, a dozen qualities here, 12 qualities, and there are hundreds of these things. I can't put them all on the picture, but what I want to point out here is that they trade off in complex and difficult ways. So, for example, and some of these things I've drawn in opposition. That doesn't mean they're necessarily in opposition in the real world. It depends on the system that you're working with. So I have performance set against maintainability. So this is a very common trade-off. I can make a system go faster if I write it in assembly, right? But it's much harder to maintain, which is why we don't write things in assembly. It's why we write things in higher level languages, which are generally slower. Okay, we pay an abstraction penalty for that. The C++ folks down at the front here are disagreeing with me, but they're definitely in the minority here. So with their cost-free abstractions. But performance and maintainability generally trade off. Some of these other things trade off in perhaps less intuitive ways. Performance tends to trade off against scalability. So and a lot of people confuse these ideas. What does scalability mean? It means I can get more work done by providing more hardware resources, typically. I can take advantage of additional resources. That kind of thing usually requires some kind of synchronization or locking, or as Kevlin Henney would call it, bottlenecks. And those bottlenecks have a performance cost. So you can scale up by going slower on each individual unit, if you like. So even scalability and performance trade off against each other. Usability and security, that's a pretty famous trade-off, isn't it? Who's ever been frustrated in their use of a system by the fact they've had to sign in to 13 different parts of the system to achieve whatever goal they want to achieve? So really the job of the software architect is about understanding these trade-offs and about choosing a habitable place in quality space, if you like. A place where your system can live and where the people who need to build the features which deliver the value can do that comfortably, and the people who use and pay for the system have a good experience too. So, trade-offs are tricky. We all know the apple is going to be better for us, but you need enough willpower to resist the Black Forest Gatto there. So this talk is very much about deliberate design for software qualities. So I'm going to call on someone who's, I guess, quite a large figure in software architecture circles. And so Grady Booch, who, that was the reference I wanted to make there. Grady Booch is, one of the things he's famous for is being deeply involved with UML, which has become very unpopular, as we discovered a few minutes ago. But Grady Booch also said some other very insightful things about the way software systems live in a context. And he encouraged us to think about the incident forces on a system. Now, as you may have gathered from my introduction, I do not have a background in computing science or software engineering, although I've been doing it professionally for 20 years and like to think I've learned at least a degree's worth of stuff along the way. My background is in the natural sciences, modeling mechanical, or in fact geophysical and rock mechanical systems, so I tend to think of things in a kind of physical way. And when Grady Booch encouraged us to understand the incident forces on a system, that conjures up a picture in my mind about how systems relate to their environment. So here we have a system. It doesn't matter what it's a solution to. You could put your own system that you're working on in your mind in that blue box in the center there. And it has incident forces on it from customers, from users. Remember, the definition of enterprise software is that those are distinct people. Business owners, the people who sell the system and market it, the developers who grow and build the system, the folks responsible for checking the system does what the system is supposed to do, the testers, the people managing the process of building the system. Other systems act as a force on your system, probably one over which you have little control. And so we can think of all these as different forces acting on the system. And what Grady Booch said is that these incident forces will resolve to zero. And that kind of makes sense, doesn't it? Because if they don't resolve to zero, what's going to happen? I mean, either your structure that you've built is going to buckle and collapse on itself until they do resolve to zero, but your system has been destroyed in the process, or your system is going to accelerate to infinity, which is probably not so good, or it's going to oscillate wildly, which is certainly something we see in the wild. So let's think about how to think about these forces with respect to your software as an engineered structure. Well, we can factor these forces into 4 groups. You can probably I'm sure you can factor them into other groups as well, but as a conceptual thinking tool, I like to use these ones. The functions of the system, the qualities of the system, which I've talked about, constraints on the system, and principles. So let's factor those forces into these 4 groups and talk about what these mean. So the functions of the system. What is it for? What use cases does it support? What goals does it allow the user to achieve? Okay? What things can people do in the presence of your software that they could not do without your software? Right? That is very much about the functions of the software. There's the qualities, which is how well does it do those things? We have this rather ugly phrase kicking around, non-functional requirements. We'll come back to that as well, but non-functional requirements are very much about software qualities. So the things I've already talked about: performance, scalability, security, maintainability, usability, fault tolerance, availability, all these things which tend not to be thought about very explicitly. There are the constraints on the system. What's it going to cost? How much money do we have? What is the budget? What does the law say about what we're allowed to do? What does the regulator say about what we're allowed to do? How much time do we have? Is there a hard deadline? Most people's deadlines are really sad lines. No one's going to die. But in some industries, there are deadlines. How many staff do we have? How many staff do we need? What experience do they have? Well, I can tell you how much experience they have. Not much, right? Because of this exponential growth, everybody has been working, or the vast majority have been working for less than 5 years, right? So most people do not have so much experience. And what principles do we choose? What architectural style are we going to select? What technology are we going to use? What standards are we going to follow? How would we like to build it? So I think it's useful to group these things in this way, and then it's useful to focus the attention of people responsible for software architecture, whether you call them an architect or not is an internal organizational concern for yourselves. But I would like to focus their attention on the qualities and the constraints. I really think this is where the attention of the architect needs to be focused. Now, to come back to this word non-functional requirements, it does tend to get confused with software quality attributes, and I do think of them in a different way. I like to put the non-functional requirements and the functional requirements as inputs to the system we're building, and the features are generally a response to the functional requirements. In order for a user to achieve a goal, we need to build some features, right? So that it supports whatever use case we're talking about. And some qualities that those users or other stakeholders will experience as a result of the system we have built. So non-functional requirements as an input and qualities as an output. Now, what's interesting to me, and the more I think about this and the more I experience it day-to-day working in projects, the more apparent it becomes, is that our approach to functional requirements and non-functional requirements is so very different. And in all the projects I've worked on, I'll be honest, some of them have failed for various reasons, for market reasons, for funding reasons, for technical reasons, okay? But very often they fail because the non-functional requirements and the qualities fall short. Not because the software doesn't do what it's supposed to do, but because it does it in just a terrible way. So let's think about how these things are captured. Well, the features, the functional requirements they're explicitly captured, right? They're on your Kanban board, they're in Jira, they're on a sticky note on your board. They're intentional. We tend not to accidentally implement features, right? They're tracked, right? We generally know whether we've implemented or not because of which column it's on the board. We can go to the software. Is the feature there? Yes. Is the feature there? No. They're deliberately designed and implemented. You can usually walk up to a developer and say, which feature are you implementing? And they can probably tell you. They're tested and verified. We write tests for features. There might be unit tests, there might be gherkin tests, there might be some manual test. Yeah. They're generally documented. Do you remember having user manuals for software? You remember that? So some of you may work in industries where you still are required to produce a user manual. The features are probably documented somewhere, how they relate to the other features, how you should use the feature. But they're essentially digital. They're either there or they're not, right? We tend not to have like half a feature. Contrast that with the qualities. They're informally captured usually, if they're captured at all. They're emergent, and I'm going to come back to this word emergent in a moment. They're untraceable. I cannot go to your code and say, well, which class is performance implemented in, right? Because that question makes no sense, right? Performance is a cross-cutting concern. It's everywhere, right? Which class is security implemented in? It's cross-cutting, right? Either your system is wholly secure or it isn't secure. They tend to be retroactively addressed. We tend to fix these things later. We can monitor them in production, which is important these days, and they tend to be undocumented. But essentially, these things are analog, right? We can have more or less performance. We can have more or less usability. And I think the fact that they're analog makes them just more conceptually challenging for us computer folks to relate to. So some people have claimed that features and qualities are orthogonal. So in a very famous book called Software Architecture and Practice, there's a statement that functionality and quality attributes are orthogonal. I'm pretty sure this isn't true, because I can make your software very secure by taking away all the features. I think we can say that ideally they would be orthogonal, but in practice this tends not to be achievable. I do want to focus, however, on the second word on the qualities list there, emergent, because this word really bothers me. So let's explore where the word emergent comes from. It comes from a fellow called George Henry Lewis, who is, as you can see, from the middle part of the 19th century. And he is a philosopher. He's not a very famous philosopher because he wasn't very good at it. He's much more famous for being married to George Eliot. Actually, not being married, being George Eliot's lover, the author. Anyway, I'm not going to read this piece of Victorian prose to you. I'm going to extract a few words from it, because this is the paragraph in which he coined the word emergent. And we can assemble this into something resembling modern English. And he says, with emergence, there is a cooperation of things of unlike kinds. The emergent is unlike its components insofar as it cannot be reduced to their sum or their difference. Right, this is quite an interesting statement. He's talking about nonlinear systems. So what do we know about nonlinear systems? Well, we know they're hard to model. We know they're hard to predict the behavior in future. And we know that anyone who here has done any control work knows that they can be hard to control. So I'd like to make an equivalence between the word emergence and nonlinear systems. So probably at this conference already you've seen somebody with a slide that has this graphic on it. It's extremely common. Normally this sapling is cradled in the nurturing hand of the software architect. And shortly after someone displays this graphic on their slide, they will utter the word emergent. And we're all supposed to feel good about it. What I'd like you to do when this happens is mentally substitute emergent for hard to model, hard to predict, and harder to control. So when somebody says emergent design, you can say hard to model design, or hard to predict design, or hard to control design. That's a bit of a mouthful, so maybe you should just say accidental. So back to my view of how software systems evolve and the process by which we make them. Most software is constructed by, these days, an agile process. There is a system which happens on a time scale of hours or days or maybe a couple of weeks, the sprint, where we iterate, and what do? We take functional requirements and we turn them into features, right? That's pretty much what we do. And essentially, the agile process is a feature pump. It just pumps features, pump, 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 on the sprint cycle, if you do that, into the system. And what happens? The system just inflates, right? Just inflates like a balloon. You're just pumping features into the system. But over time, qualities emerge. And you don't get any choice over whether these qualities emerge. They will emerge, right? This is the nature of emergent qualities. Okay? So whether you designed for it or not, your system will have a usability, it will have a maintainability, and it will have a scalability, and all these other qualities that we talked about. But they don't emerge over hours and days and weeks. They emerge over months and years, right? People realize that the usability has become bad over a year after they start adding the features in. And of course, it's very complicated, isn't it? Because if you take a feature and another feature Well, if you add one feature, the system has a usability. You add another feature, does the usability go up or down? It's complicated, right? It might go down. Some systems are overwhelmed by features, so people can't even find the feature they want, right? So that's a good example of emergence. The usability emerges in a complex, nonlinear way from the inputs. And it emerges over time, a much longer time scale. And so thinking about control theory again, you get this kind of signal coming out of the system, which is the wellness of it, which is the collection of quality attributes. And these emerge over a much longer time scale than your agile time scale. And that's like having a really brutal low-pass filter in your signal processing loop. And anyone who's done any signal processing or control knows that that makes it very hard to figure out what the current state of the system is and to respond to it in a timely way. And so this signal, the difference between the usability, what the usability is and what it should be, or what the performance is and what it should be, tends to get encoded in a very cryptic way into large numbers of defects, which go into Jira to die. So Jira is really just a buffer. It's a part of a very low-pass filter system in the agile feedback loop. So the only hope for getting these qualities to come out anything like the way you want them to come out is to deliberately design for them. And this is really where software architecture fits in. You know, people ask me, where does software architecture fit into Agile? Because it doesn't. And the answer is, it needs to, because deliberately designing for constraints and qualities, whilst at the same time facilitating the delivery of the features, is really what the software architecture is for. Winston Churchill said it better than me. Actually, Winston Churchill said everything better than most people. However beautiful the strategy, you should occasionally look at the results. So really, I think the job of the software architect is to navigate this very complex landscape, fitness landscape. I mean, it really is a fitness landscape. There are good places to be in this landscape, and there are bad places to be in this landscape of quality, software quality trade-offs. And the challenge we have as architects is that we don't get this godlike view where we can see the landscape, right? It's invisible to us. It also doesn't have two dimensions. I've worked on really difficult two-dimensional optimization problems, but software architecture is a kind of 96-dimensional, really difficult optimization problem. Getting the right trade-offs, finding a habitable zone in quality space for our software to live so that it exhibits the right qualities and we can deliver and supports the delivery of features. So I'm really here to advocate, I suppose, software architecture, at least some consciousness of software architecture, as a counterbalance to what I would call agile featureism. I love the way this crane says reliable on it. So to a large extent, functionality is independent of structure. We can make systems which essentially have identical functionality and very different structures and different qualities. So this is almost a cartoon example. It's so simple. But anybody here should be able to appreciate this. We have Twitter, right, which is where I spend the other half of my life. And we have a web application, and we have a native iOS application, right? They both have essentially exactly the same features. They allow me to read your tweets and allow me to send you just content-free nonsense throughout the day, right? But these systems have different qualities, right? They might have the same usability, but the performance of the native application might be better than the web application. The maintainability of the native application, let's say it's written in Swift, right? I'm going to guess that a nice application written in Swift has better maintainability than the web app written in JavaScript, say. Deploying the web application might be straightforward in that we can deploy it very quickly and rapidly, whereas the iOS application, we're going to require the user to go through a process of updating the app, right? So we have much less control over which version of the client our users are using, right? So we have to support many different versions of the client, Whereas the web app, we have a lot more control over which version of the client we're using, because they can only use the one we've just given them, right? The portability is very different though, isn't it? I can move the web app between browsers. I can even move the web app to the phone, because I can run the web app on the phone as well. Whereas the portability of my native iOS application is probably pretty low. It's written in Swift, right? So what do we do about that? So what I'd like you to encourage you to do is, when you are choosing a software architectural style, and I'm not for or against any particular software architectural style, all I'm asking people to do is to choose a software architectural style consciously based upon the qualities that it has, because that is what architectural styles are for. They are known combinations of software quality attributes. And so if you want your software qualities to come out in a particular way, what you need to do is choose an architectural style which is known to exhibit those qualities. Okay? So, you know, there are cases where the layered monolith is a more appropriate thing in your context than the microservice. I'm working on a project for a client at the moment where I'm not the architect of it. I'm consulting on it in another capacity, and a microservice architecture has been selected, and frankly, the performance is appalling, right? Because there's just so much latency between different services waiting for each other and talking to each other that the thing has become not quite unusable, but it's heading that way, right? So, of course, performance correlates with usability as well, or tends to. So, I don't often spend my evenings reading other people's PhD theses. I know there are people here who do, and I occasionally do. So here's one particular thesis, which I'm sure at least one gentleman in the front row has read, probably once a week. And this is Roy Fielding's thesis from 2000, and this is the paper in which he developed, or the thesis in which he developed what is now the RESTful architecture. Unfortunately, most people missed the point of what he was trying to say. That's off topic for today. But if you read this and get as far as page 15, he says this: some architectural styles are often portrayed as silver bullet solutions for all forms of software. However, a good designer should select a style that matches the needs of the particular problem being solved. Right? That's what you need to do. That's the message here, is choose a style based on the needs and based upon the qualities it's known to exhibit. In the world of building architecture, other people have said similar things. Personal stylistic concerns have no place in the work of the professional architect, right? This is a statement about correcting for those cognitive biases that we talked about earlier. So how do we deal with this? Well, you probably work in a process that looks something like this, whether it's sticky notes or Jira, probably Jira. And, you know, work progresses from left to right across your board. And what the Agile folks told us to do is they said, well, to accommodate qualities, because remember, we can't have a sticky note that says performance or scalability or security, because that's just not something you just implement in one place, right? It's a cross-cutting concern. It affects every feature. Every feature that goes across this board has to maintain the performance. Every feature that goes across this board has to maintain the maintainability. It has to maintain the usability. It has to maintain the scalability, right? They're cross-cutting. That's why they're so difficult to deal with. So the traditional Agile coach response to this is, well, this is easy. You just need to build the qualities into your definition of done. And it's not allowed to be done, right, until, you know, the code is written, it's been checked in, obviously, it was reviewed, or you paired on it when you wrote it, you've written all the tests at different levels, it does actually implement the feature, and it doesn't degrade any of the software qualities below acceptable levels, and ideally improves them in the directions we would like to go. And this is from Mike Cohen of the Scrum Alliance, and this is one of those things that is wonderful in theory. In practice, I've only ever seen this, which is that people can be very creative in adding columns to these charts, right? And the state chart for work becomes ever more complex and involved because we have almost done, nearly there, you know, it works, but it isn't fast, or it works, but nobody knows how to use it, or it works, but the thing no longer scales, right? So, in fact, I don't find this works very well at all. So, really you need, I think it's very difficult to correct for these at the time you're developing features. You need to build systems where these things naturally emerge in the right way because you've chosen an appropriate architectural style. Sometimes, though, you need to, monitor these things in production, right? So we can monitor usability. How? We can measure how many people who visit the product actually achieve the goal, right? Or versus how many people bail out. We can monitor performance. We can monitor maintainability. How long is it taking us to do stuff? Portability is more difficult. How do we deal with that? Well, if you have something like an operating system, like Mac OS, right? That ran on PowerPC for a long time. Now it runs on Intel. In a couple of years, we're all going to be using it on ARM, right? You can't monitor for that, but what you can do is plan for it. You can say, well, we have an operating system. It's probably a good idea if it's portable, right? And what Apple did is they paid some guy basically to sit and maintain Mac OS on Intel for years before anybody knew that we were going to get Mac OS on Intel, right? I'm sure there's somebody there doing the same on ARM now. So, so we're just coming to the conclusion now. So lots of people have a stake in your system. Lots of people care about your system. Most people are most of these stakeholders, and there are many, many of them, if you think, just take a few minutes to think about who they all are. Most of these people are focused on features. That is what their life entails. It entails implementing features, using features, selling features, testing features, managing tickets across the Kanban board, managing features, training people how to use features, writing about features, 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 features. There are plenty of people thinking about features. You are not going to forget the features. So I'd like to advocate the role of the architect as somebody who thinks about something else. The one person who really thinks about the qualities of the system and defends those qualities against attack by other stakeholders, or erosion is probably a better word. So I'm going to finish on one piece of advice in the final few minutes here, which is very simple, it's easy to remember, and it has served me very well. And it was told me by somebody I worked with. They were told it by somebody else, and I cannot track down the origin of it. So if the person who came up with this quote is in the room, please reveal yourself, and I will attribute you. But the advice is very simple. As a software architect, even if that's not on your business card, if you are the person who looks after the architecture of a system, you look after the quality attributes. In fact, if you really just focus yourself on the qualities of the system, okay, plenty of other people are going to be focusing on the features of the system. This is really all you need to do. You need to produce a system which is able to support the feature development and facilitate the feature development, but which delivers systems with the right combination of qualities under the constraints that you're operating under. Thank you very much.